Okay, so section 2.4. So we have two main things in here. There's what's called interval notation. So for example, if you have a number line, and let's just pick a number, let's say 4. And if your number line looks like this would be written as 4 to infinity, because it's starting at 4, it's going all the way up to infinity. If it was with a square bracket, see this one up here is just like a regular parentheses. If it was a square bracket, all right, then over here you put a square bracket. And what the difference is, this one would be x is greater than 4. This one would be x is greater than or equal to 4. So if it has the underline, it's going to be the square bracket like this. Okay. Now, if it was going the other way, let's say it was 3, and it was shaded this way with the rounded one. So you always go left to right. So this thing is way out here. Negative infinity is way out here. And then it's working its way to the right to 3. So you write it like this. Okay, and one thing to notice, the infinities always have the rounded one. No matter what the symbol is over here, the infinities or negative infinities always have the rounded parentheses. So let's just look at one more. If, let's say, this was -2 with a square one. So again, I come left to right. I go negative infinity to -2, and it would have the square bracket. And if you had any, so what these ones would look like is x is less than 3, or x is less than or equal to -2. Now also in this book, they also use sometimes what's called set builder notation. It's kind of weird, like say for this one, I'll just pick a random one. So you'll see it like this. You may have seen this somewhere. So the way you read this is you say x such that x is greater than or equal to 4, but in reality, you really just need to look at that part of it. This other stuff, it really doesn't do anything, honestly. So like this one, x such that x is less than 3. All right, but again, all you really have to focus on when you see that is that right there. That's telling you everything you need to know. And just one last one. If you were to see something like this, sometimes it's between two numbers, like say 4 and 10. And it could be one of each. It could be both the same. Let's say this one's a rounded one and this one's a square one. And so your notation would be exactly what you see there. It would be like this, 4 and 10. So you pretty much just kind of copy exactly what you see there without the shading. All right. And then the actual solving, so let's say we had 2x plus 1 less than or equal to 7. Okay, so I just solved it like a normal equation. 2x is less than or equal to 6. Divide by 2. X is less than or equal to 3. And so what that's going to translate, if it helps you to draw the number line, go ahead, even though it may not be required. So this one is saying less than 3, and it's underlined, so it's going to be the square one. And so what we really want is the interval notation, though. And so this one would look like this. Okay, so this right here is kind of optional. And this right here is what we really want to get at for the answer. And so when you're solving inequalities, it's very similar to equations. There's one big difference you may remember. Like if you were to have something like this. Okay, so you go -1, sorry, -2x is greater than 6. Now if I divide by a negative, okay, so the rule actually is if you multiply or divide by a negative, see right here, what happens is the sign switches. So from here to here, you see how the sign switched? When you multiply or divide by a negative, the sign will switch. And so this one would be like this. Okay, so that's the main thing with inequalities. You could see, very similar to equations, you could have distributive property. So 2x minus 2 plus 4. And then I put these two together, the negative 2 and the 4. So 2x plus 2, subtract 2, divide by 2. Nothing switching on this one. So it would be 3/2 with the square bracket, and then all the way out to infinity. Okay, so very similar to solving equations. One thing to keep in mind, I'll just run through a real simple one. Let's say 2x plus 4 greater than 2x plus 1. Okay, so 2x plus 4 greater than 2x plus 2. Right, now what would you normally do here? I would normally subtract 2x from both sides. And you see what's going to happen. This is kind of a weird one. The x's completely disappear. And so what I have to do is I have to look at this line here. 4 is greater than 2. If that's true, which it obviously is, then my answer is everything. It's called all real numbers. Okay? If that had come out false, like just for example, let's just say it had come out 4 is greater than 7. And obviously that's false. My answer in that case would be no solution. Okay, so if the x's completely disappear, then what you do is you look at this line here, and that will tell you if it's true, your answer is everything, all real numbers. If it's false, your answer is no solution. Okay, now let me just run through one last one with fractions, because I know sometimes that's an issue for people. Okay, so let's just try this one. And so typically what we do when there's fractions involved, we find the LCD. Okay, so you have this 3 here and this 2 here. So your LCD is 6. Those are not negatives. I was just making little marks there. So I'm going to multiply everything by 6. So I go 6 over 1 times 2/3 x. The 1 also gets timesed. And then 6 over 1 times 1/2 x. Okay, again, remember those aren't, in fact, let me see. Take those out of there. Okay. All right, so I multiply everything by 6. So over here, 6 times 2 is 12, over 3 is 4x, plus 6. Over here, 6 over 2 is 3. Okay, now normally I would subtract 3x from both sides, but that's going to leave me with a 0. So I'm going to try it like this. Now I have 6, and then I have negative x, and that negative's no good. So I'm going to divide by a negative 1. Now remember, that's going to switch your sign. So this is now positive x. This is negative 6. And I'm kind of glad this came up. Sometimes people get confused on this. When the x ends up on the right side, what you might want to do is switch it around. So keep in mind, it's pointing at the x here. So if I switch it around, it has to be pointing at the x as well. And for some people, it's easier if the x is on the left. So this is saying x is less than or equal to negative 6. And so my answer would look like this. All right, so hopefully that helps. Kind of look back through here. 2.4. So it starts with just basic interval notation. And then the inequalities, none of them are going to be super complicated. trying to just kind of get through the basics here. So hopefully that'll help you.